November 14th, 1942. 23:33 hours. The Pacific Ocean is a sheet of obsidian, broken only by the wake of the USS South Dakota. Deep within the Savo Sound, the air inside the ship's citadel is thick, tasting of ozone and recycled breath. Suddenly, the world ends in a flash of blue light. It isn't a Japanese shell yet. It is the sound of a massive electrical surge, a mechanical scream that echoes through the bowels of the ship. In an instant, the pride of the American fleet, a billion-dollar fortress of 16-inch guns and state-of-the-art radar, becomes a 35,000-ton steel coffin. The lights vanish. The cooling fans die. Most importantly, the fire control computers and the brains of the ship go silent. Out in the darkness, the Japanese battleship Kirishima and her escort of cruisers are closing in. Their long-lance torpedoes already sliding into the water. The most advanced warship on Earth is blind, dead in the water, and drifting into the path of an entire enemy fleet. While the admiral stares at empty radar screens, a lone mechanic in the humid darkness of switchboard room number 2 reaches for a roll of friction tape and a pair of pliers. This is the story of how a single improvised repair saved a battleship from the bottom of the Pacific. By November 1942, the struggle for Guadalcanal had devolved into a grueling war of attrition that neither side could afford to lose. To the Americans, the island was a vital foothold in the Solomon Islands, a shield for the supply lines to Australia. To the Japanese, it was a bleeding wound that threatened the entire perimeter of their empire. The focus of this violence was a single strip of dirt, Henderson Field. Whoever controlled the airfield controlled the skies by day, but by night, the waters belonged to the Imperial Japanese Navy. The Japanese had perfected a system known as the Tokyo Express, using fast destroyers and cruisers to ferry reinforcements and supplies down the slot under the cover of darkness. However, these small-scale runs were no longer enough. Admiral Isoroku Yamamoto realized that to truly reclaim the island, he needed to silence Henderson Field permanently. This required the heavy metal of the Imperial Navy, the battleships. The naval battles of mid-November were born of this desperation. 2 days prior, a brutal close-quarters engagement had left both sides battered, but the Japanese were returning with a fresh, heavy bombardment force centered around the battleship Kirishima. The American situation was dire. Most of their cruisers were damaged or resting at the bottom of what was now called Iron Bottom Sound. Admiral Richmond Kelly Turner had only one card left to play. He detached Task Force 64, built around the new, fast battleships USS Washington and USS South Dakota. This was a radical gamble. Conventional naval doctrine of the era dictated that battleships were too precious and too unwieldy to be risked in the narrow, treacherous waters of a sound at night. These were ships designed to trade blows at 15 miles on the open sea, not to duel at point-blank range in a graveyard of sunken ships. But as the sun dipped below the horizon on November 14th, the South Dakota steamed toward the Sound, carrying the weight of the entire Pacific campaign on her teak decks. She was a technological marvel, yet she was heading into an environment where technology often succumbed to the primal chaos of night combat. The USS South Dakota represented the pinnacle of 1940s naval engineering. As the lead ship of her class, she was designed to pack the punching power of a 16-inch gunned dreadnought into a hull that was shorter and better armored than her predecessors. She was a compact powerhouse, designed to withstand the very shells she fired. But her true advantage wasn't just her steel skin, it was her nervous system. Unlike the older Japanese ships, the South Dakota was integrated with a sophisticated electrical network. This system powered everything from the massive hydraulic pumps that rotated her 200-ton turrets to the delicate vacuum tubes of her Mark 8 fire control radar. This radar was the unfair advantage the Americans held as a way to see the enemy through the smoke and tropical gloom before a single flare was ever dropped. However, this complexity was also a hidden vulnerability. The ship's electrical distribution was managed through a series of complex switchboards and circuit breakers designed to isolate damage. But a fatal design oversight existed: the sensitivity of the circuit breakers. To protect the ship's advanced electronics from power surges, the breakers were set with incredibly tight tolerances. Furthermore, the ship's chief engineer had recently made a controversial decision during a maintenance period bypassing certain safety interlocks to ensure the ship could maintain power during heavy maneuvering. On the night of November 14th, the South Dakota was operating under a split bus configuration. This meant that if one part of the ship's grid failed, it shouldn't take down the rest. But as the ship prepared for combat, the vibration of her own massive engines and the impending shock of her 16-inch guns created a volatile environment for the delicate switchgear. The crew believed they were sailing in the most survivable ship in the fleet, unaware that a single loose nut and a surge of stray current were about to turn their high-tech fortress into a silent, floating target. In the era of the big gun, night combat was a chaotic, terrifying gamble. Tactical doctrine for the U.S. Navy was still catching up to the reality of the Pacific theater. At Guadalcanal, the confined waters of the Sound, surrounded by islands that created ghost radar returns, meant that a battleship's reach was effectively neutered. The tactical plan relied on the USS Washington and the USS South Dakota operating as a cohesive unit, using their radar to pick off Japanese targets from a distance. However, the reality was a nightmare of visibility. The Japanese were masters of night fighting, using long-range binoculars and powerful magnesium flares that could turn midnight into high noon. Tactically, the South Dakota was in a precarious position. She was the trailing ship in a two-ship line, following the Washington into a narrow channel where maneuvering was limited. If she lost her ability to see or steer, she wouldn't just be useless, she would become a massive physical obstacle for her sister ship, potentially leading to a collision that would end the American presence in the Solomons. The South Dakota was a pioneer of the CIC Combat Information Center, a centralized hub where radar data, sonar, and visual sightings were synthesized. This was the birth of modern naval warfare. The Mark III and Mark VIII radars allowed the ship to track multiple targets simultaneously, feeding coordinates into mechanical analog computers that calculated lead and elevation for the guns. This technology promised blind fire capability, the ability to sink an enemy you couldn't even see with the naked eye. But this reliance on electronics created a glass jaw. The vacuum tubes and wiring were sensitive to the massive concussive force of the ship's own 16-inch guns. Every time the South Dakota fired a broadside, the shock wave was equivalent to a localized earthquake. The technology that made her a predator also made her delicate. On this night, the very systems meant to ensure her dominance were one vibration away from a total catastrophic failure, revealing the thin line between a futuristic warship and a helpless hunk of iron. Below the armored waterline, the war was not fought with binoculars or radar screens, but with sweat and steel. For the snipes, the machinists and boiler technicians, the battle was a sensory assault. The ambient temperature in the engine rooms hovered near 105 degrees C, 40 degrees, humid and thick with the smell of heavy fuel oil. These men were trapped in a labyrinth of high-pressure steam lines and whirling turbines, hearing the muffled thuds of distant shells without knowing which one might turn their compartment into a pressurized oven. When the electrical failure struck, the horror was immediate. The massive ventilation blowers died, and the temperature began to climb instantly. In the absolute, crushing darkness of the lower decks, the only light came from the blue, sparking arcs of short-circuiting switchboards. Men had to navigate by touch and memory, their hands finding familiar valves and levers in a pitch-black tomb, knowing that if they couldn't restore power, the thousands of sailors above them were defenseless. Rear Admiral Willis Ching Lee was a rare breed, a tactical genius who understood the math behind the machinery. A former Olympic gold medalist marksman, Lee knew that his two battleships were the last line of defense. From his flagship, the Washington, he had to manage a chaotic battlefield where friend or foe was a question of seconds. His leadership was tested when the South Dakota suddenly vanished from his tactical picture. He didn't know if she had been torpedoed, if she had turned away, or if she was about to fire on him. Lee had to make the agonizing decision to press the attack alone against the Kirishima, essentially leaving the South Dakota to fend for herself in the dark. It was a cold, calculated gamble, save the mission, even if it meant losing his most powerful subordinate. Vice Admiral Nobutake Kondo, aboard the heavy cruiser Atago, scanned the horizon with his elite lookouts. They were the best in the world at night spotting. When the South Dakota lost power, her silhouette was momentarily lit by the fires of burning American destroyers. To Kondo, this was a gift from the gods. He saw a massive American battleship drifting, silent and seemingly abandoned by her escort. He didn't see a threat. He saw a trophy. He ordered every available gun and torpedo tube to train on the ghost ship. To the Japanese, the South Dakota's silence was a sign of defeat, and they prepared to deliver the coup de grace with a barrage of Type 93 Long Lance torpedoes and 14-inch armor-piercing shells. 23:33:05 hours. The South Dakota is in the middle of a high-speed turn to avoid the burning wreckage of the destroyers Preston and Walk. On the bridge, Captain Glenn Davis feels the ship shudder. It isn't a hit. It is the sound of the number 4 switchboard exploding. The failure is a cascade, a circuit breaker improperly set to a too sensitive threshold, trips under the immense vibration of the ship's own movement. Because of the hand-tied bypasses made earlier by the engineering staff to ensure continuous power, the surge doesn't stop. It jumps. In less than a second, a feedback loop of high-voltage current races through the ship's electrical spine. The effect is total. One moment, the ship's Mark 8 radar is tracking the Japanese cruiser Sendai. The next, the screens flicker and die. The gyros, which provide the stability for the 16-inch guns, begin to spin down, losing their orientation. The electric ammunition hoists stop mid-climb, leaving the massive shells dangling in the dark. Most catastrophically, the steering gear freezes. The South Dakota, 35,000 tons of momentum, is now locked into a turn that is taking her directly toward the Japanese line. She is in the spotlight. The Japanese have dropped illumination flares, and the South Dakota stands out like a mountain of gray steel against the black water. To the crew on the bridge, the silence is more terrifying than the gunfire. They are a sitting duck, unable to see the enemy, unable to aim their guns, and unable to maneuver. They are waiting for the impact of shells they cannot even track. As the South Dakota drifted into the Japanese kill zone, Kirishima and her escorts opened fire. The first 14-inch shells from the Japanese battleship screamed overhead, splashing into the water with geysers of white spray that towered over the American decks. On the bridge, the officers were blind. In the plotting room, the computers were dead. But deep in the ship's gut, Chief Petty Officer CPO Miller and a handful of electricians were fighting a different kind of war. The air in switchboard room number 2 was thick with the acrid stench of burning bakelite and copper. By the flickering light of a single emergency battle lantern, Miller saw the carnage. The main circuit breakers had not just tripped. They had practically welded themselves shut from the heat of the surge. The locked-in configuration meant the power couldn't be reset the standard way. With the ship shuddering from near misses and the deafening clang of 6-inch cruiser shells beginning to pepper the superstructure, the mechanics realized they couldn't follow the manual. The manual assumed a ship that wasn't being hunted. Working with frantic precision, a mechanic historically noted for his make-do grit used a pair of insulated pliers to manually pry the fused contacts apart. To prevent another immediate arc-over, they used what they had on hand: heavy friction tape, the 1942 equivalent of duct tape, and pieces of discarded rubber matting to provide makeshift insulation where the original porcelain had shattered. They were hot wiring a battleship. At 23:36 hours, after 3 minutes of total paralysis, the miracle happened. Miller slammed the manual bypass closed. A hum returned to the ship. Above decks, the radar screens pulsed back to life. The gyro compasses began to whine as they regained their true north. The turret captains felt the vibration of the ammunition hoists moving again. The South Dakota wasn't out of the woods. She was still being hit by a relentless barrage of shells that were shredding her upper works, but she could finally fight back. The mechanics, drenched in sweat and nursing electrical burns, stayed at their posts, physically holding the bypass breakers in place as the 16-inch guns of the main battery finally roared in retaliation. The Ghost had come back to life. The South Dakota had regained her pulse, but the price of her technical paralysis was written in fire and twisted steel. Because her electrical failure had forced her to draw the attention of the entire Japanese bombardment force, she had inadvertently acted as a massive armored decoy. For nearly 20 minutes, the Japanese fleet focused their fury on the South Dakota, convinced she was the only American capital ship in the area. This tactical tunnel vision was a fatal mistake for Admiral Kondo. While the South Dakota endured a localized apocalypse, taking 26 hits from major and medium caliber shells, the USS Washington remained undetected in the darkness. Steaming just a few miles away, Admiral Lee used the South Dakota as a reference point. As the Japanese shells illuminated the South Dakota's silhouette, they also revealed their own positions to Washington's superior radar. At 00 hours on November 15th, Washington unleashed a devastating broadside. In 7 minutes, she pumped 75 16-inch shells into the Kirishima, turning the Japanese battleship into a blazing wreck. The South Dakota, though battered and bleeding, had survived. Her superstructure was a graveyard of shattered teak and mangled radio masts, and 38 of her crew were dead, with another 60 wounded. Yet, the hull remained unbreached below the waterline. The ship withdrew under her own power, a testament to the resilience of her design and the ingenuity of the men who had refused to let her die in the dark. The Ghost of Guadalcanal had been struck by more heavy shells than any other American battleship to survive the war. Had the mechanics in the switchboard rooms failed to bridge those circuits, the South Dakota would likely have been finished off by torpedoes, and the Washington might never have found the opening to sink the Kirishima. The survival of the USS South Dakota sent shockwaves through the Bureau of Ships. When the battered giant finally limped into New York Naval Shipyard for repairs, engineers didn't just look at the shell holes, they looked at the melted copper in switchboard room number 2. The report that followed was a scathing indictment of over-engineering. The Navy realized that their obsession with safety had created a paradox. The circuit breakers were so sensitive that they protected the ship's electronics by rendering the ship defenseless. The split bus configuration, meant to ensure redundancy, had actually allowed a single localized surge to migrate across the entire grid because of the improvised bypasses made by the crew. As a direct result of South Dakota's blackout, the Navy overhauled the electrical doctrine for the entire fleet. Circuit breaker tolerances were widened to endure the concussive shock of 16-inch gunfire. Emergency lighting was decentralized, and damage control teams were issued new, standardized jury-rig kits, essentially pre-made bypass cables and high-grade insulation materials so that future mechanics wouldn't have to rely on friction tape and rubber mats. The battle also settled the big gun versus technology debate. While the radar had initially failed, its ability to help Washington finish the Hiroshima proved that the future of naval warfare lay in the electromagnetic spectrum. However, the South Dakota served as a permanent reminder that no matter how advanced the computer, the ship's survival still rested on the shoulders of a man with a wrench, standing in the dark, refusing to quit. The saga of the USS South Dakota at the Battle of Guadalcanal remains one of the most stark lessons in the history of naval warfare. It is a story of the thin, vibrating line between a masterpiece of engineering and a useless hulk of floating iron. In the decades since, the blackout at Savo has been studied not just by historians, but by systems engineers and disaster response specialists. It serves as the ultimate case study in cascading failure, how the very systems designed to protect a vessel can, under the stress of combat, become the instrument of its undoing. But beyond the technical reports and the redesigned circuit breakers lies a more profound human truth. On that night in 1942, the Pacific War moved into a new era of push-button warfare, where targets were blips on a screen and death arrived from beyond the horizon. Yet, when the high-tech sensors failed and the brains of the ship went dark, the South Dakota didn't sink. She was held together by the grit of sailors who understood that machines are only as capable as the men who maintain them. History often remembers the admirals who give the orders and the gunners who pull the triggers. We build monuments to the 16-inch shells and the radar masts. But the survival of the South Dakota was won in a cramped, sweltering compartment by a mechanic who didn't have a manual for the crisis he faced. Armed with nothing but a roll of tape and the refusal to let his ship go down in silence, he proved that even in the age of the superweapon, the most critical component of any machine is the human spirit. The South Dakota would go on to fight in every major campaign, from the Gilbert Islands to the shores of Japan, eventually standing as a witness to the surrender in Tokyo Bay. She bore the scars of Guadalcanal for the rest of her life, a reminder that while technology may win battles, it is the ingenuity of the underdog in the engine room that saves the day.